We live in an amazing time. It is a time in which the world is moving swiftly from a period of no electronic computing at all to a time when computing is literally everywhere. All of this has happened in less than a century, which in the sweep of human history is merely the blink of an eye. To my son and daughter, who are both in college, it is unthinkable that we ever lived without computers and software and smartphones and laptops and tablets. None of that. To those of us in our generation, in the field of what we like to call here the field of contemporary history, we have an obligation to them and to future generations to tell that story, to tell the story of how we got from there to here. It's happening so quickly, and it's easily lost. Measuring the ongoing impact of computing on the human experience is central to what this museum does. It's why we come to work every day. The most interesting part of that story to me is the story of the people who have made it happen. We specialize in people stories at the Computer History Museum. We try, whenever possible, to tell the story of technology through the people who made it happen and the people whose lives were moved by it. Over time, I've learned that the people involved in tremendous breakthroughs which have changed things forever mostly share certain basic qualities. I have 3 qualities in mind. First, to put it very simply, they all really just had a vision about how to solve a problem. Second, most of them had been told the problem was extremely difficult, if not impossible, to solve. And third, most of them describe their work and their breakthroughs in the most humble of terms. They say things like, "We stumbled onto it," or "We had to do it on the side because we had day jobs," or my favorite, "Once we got into it, we found out it would be a lot harder than we thought it was going to be." It's a wonderful and inspirational thing. Such is the story of Plato and the story of Don Bitzer and of the many men and women who have contributed to Plato's fantastic staying power over 50 years. Don Bitzer had a vision. He found people who were talented and relentless, and he led them in their relentless pursuit of it. Together, they built a system that first did something no one had ever done before, which was distributed computer-based learning. But secondly, and quite unexpectedly, they harnessed a culture of innovation which produced the forerunners of an astounding universe of applications. Today, we take for granted social media, online gaming, digital education, network communities, the list goes on and on. Plato was an early platform for all of this and more. Telling that story, recording and recounting the history, and featuring and honoring the important people who were involved, or at least as many of them as we've been able to collect for this reunion, is what Plato at 50 is all about. I've saved one more thank you for this moment, and that thank you goes to Brian Deer. Brian has a day job. He is the founder and chairman of Eventful Incorporated, which is the maker of the world's largest event search engine, Eventful.com. Before that, he was with eBay, and he led the eBay Design Labs. He's done many other things. Those are just 2 highlights of a 25-year career in online application and online communities. But his sideline, his obsession, his passion, the one we know him for best here at the museum, is as the founder of the Plato History Foundation and the author of the forthcoming book, The Friendly Orange Glow. Brian has been researching the roots and legacy of Plato for 20 years, which is what you do when you're busy doing other things. He came to us more than a year ago, and he convinced us that this conference would be a wonderful idea, and he was right. His archive of more than 400 interviews and a massive amount of documents make him uniquely qualified to kick off tonight's event with an overview of 50 years of Plato. 50 years of Plato. So hang on to your hats, because he's going to cover 50 years in 15 minutes. Please join me in welcoming and thanking Brian Deer.
Thank you very much. Thanks, John. Before I start, I'd really like to just offer my thanks too. This is my first conference, and I've never gotten up on stage and thanked everyone, how this happens, but here I am, and now I understand it. So give me a moment. I want to thank the entire Computer History Museum. This has been just a wonderful relationship, and this is a dream come true, and thank you. To all the many volunteers who helped make this possible, to the moderators and the panelists, and to the cyber1.org crew, to Aaron Wolfson and Bob Morris, whose artifacts are out in the Plato playground that you must see, to Microsoft and Plato Learning for their incredible support, without whom this conference simply would not happen. And finally, to my wife, Pat, who I met online on Plato in a term talk in 1984. And in just a few weeks, we're celebrating our 25th wedding anniversary. So thank you. History doesn't repeat itself, but it does rhyme. It sure does, and I have a hunch that you may agree by the time this conference is over. It's my hope that through this conference, it gives you a glimpse, at least, of what the future looked like to Plato users 30, 40, 50 years ago. Plato at 50. Did you know that 50 years is 438,000 hours? And I've got now 14 minutes to try to cover that span of time, so fasten your seatbelts. My overview actually starts all the way back to 1912. I figured this was as good a place as any to start a 50-year presentation. In 1912, a psychologist, Edward Thorndike, wrote the following passage, hinting at the future to come. If by a miracle of mechanical ingenuity, a book could be so arranged that only to him who had done what was directed on page 1 would page 2 become visible, and so on. Much that now requires personal instruction could be managed by print. Kind of an early hypertext vision there, I think. Over the following decades, behavioral psychologists began studying human learning using mechanical teaching machines. Teaching machines were attractive because they enabled individualized instruction, where each student could work and progress at his or her own pace, which was something that was very unlike the typical classroom setting. In 1957, the Soviets launched Sputnik. Among the positive outcomes from the strong national outcry was money. The US government began pouring out money to improve math and science education across the nation, money that would eventually fund Plato. In 1958, the first conference on automatic teaching was held, and one notable presentation was from IBM, who, unlike other presenters with their Rube Goldberg-like teaching machine gadgets, had used a computer, an IBM 704, as an automated teacher. And among their conclusions, one, software is a heck of a lot easier to modify than mechanical devices. And two, time sharing sure would be nice. They didn't have it then, but they realized it would be advantageous, and there's no reason to dedicate a huge hulking computer at the time to just one student when it could be used to support multiple students. Now, at the University of Illinois, the Control Systems Lab, formed during the Korean War to do classified military work, got a new director, Dan Alpert, who was a physicist, around the time of Sputnik. Alpert wanted to declassify the lab, and he was looking for ideas for unclassified projects. Chalmers Sherwin, who was another CSL physicist at the time, was known for asking really intriguing questions. And one day he asked, there hasn't been an invention in the field of education since the book. Why can't computers be applied to education? And as a result, Alpert formed a committee to look into the idea. And they argued for weeks, getting nowhere. On May 6, 1960, the committee submitted their final report. It was basically, great idea, but we can't agree on what the teaching machine should teach as a subject, and we don't think that you're going to find one person who, A, knows how to teach, B, knows computer and hardware and software, and C, can lead a project, so we think we should pass. Alpert wrote a memo to the Dean of Engineering summarizing the committee's negative conclusion, but he didn't send it. He didn't want to break the bad news. And after a few days, he had an idea. What if the subject matter were simply how to program a computer? That'd make it easier to find someone who was a subject matter expert, who had experience teaching, and who had the technical chops to make the project happen. So he asked then 26-year-old Donald Bitzer, who'd already done great work on radar and computer systems at CSL, who'd just gotten his PhD in electrical engineering, "You want to take this on?" Bitzer agreed to take the project on and got started right away. On June 3rd, 1960, tomorrow, 50 years, Albert submitted a revised memo to the Dean of Engineering, here it is, saying, "Hey, we've got a couple of really cool projects coming. One of them is an automatic teaching machine." And given CSL's military background, I don't think it was surprising that Bitzer and company picked a Pentagon-friendly acronym for the new project, Programmed Logic for Automated Teaching Operations, or PLATO. And thus, PLATO was born. Now, this equipment diagram, made in the summer of 1960, laid out the various components that they envisioned would be part of this PLATO system. And I've always found this really fascinating. At first glance, it's so simple now when you look at it, and maybe even kind of primitive. But look at the year. This is 1960. And I think it's fair to say what Don and company realized is that they would have to build pretty much everything you see here from scratch. Luckily, there was a digital computer already around at CSL. For starters, PLATO would run on the Iliac 1, parts of which are now here at the museum. And PLATO would need a very high quality graphics display if this machine were going to really teach any subject, and not just how to program a computer. Early PLATO was based on simple television sets using storage tube memory, and to make PLATO economically viable, it was going to have to scale really big. They'd need something besides expensive storage tubes or expensive RAM to drive the displays. In 1960, RAM cost around $2 a bit per bit. Now, your basic 2 gig Mac today would cost about $34 billion. You could almost get a little Apple stock for that. The eventual solution, which they invented, patented, and finally shipped in production in 1972, was the gas plasma flat panel display. You're going to hear all about it tonight from Don and in tomorrow's hardware session. Now, the PLATO team, right from the very start, realized this is no ordinary computer system they're building. Remember, you're supposed to be interacting with an automated teacher. And that, the system had to have 2 key components. One, it had to be infinitely patient, as any teacher should be if they're, the ultimate teacher. And number 2, it should be instantly responsive to keyboard input. And it was therefore imperative that the keyboard response be as fast as possible. And as you're going to discover throughout the conference, this insistence on speed would turn out to be one of the not only crucial to PLATO's effectiveness with students and learning, but also to the growth of the online community with instant messaging and chat rooms and multiplayer games. In 1961, the PLATO 1 system became PLATO 2, now with time sharing and the ability for 2 students to use the system simultaneously. And if you can have 2 students, you can have n students. And so it wasn't long before PLATO 3 arrived, and you can see this terminal out in the playground, with a new Control Data 1604 CPU and support for more simultaneous students. Creating and editing courseware on PLATO was labor-intensive and basically done in Fortran. But it would there were some major changes that were coming about, major software innovations, including an on-screen editor. That was a huge step forward for creating and testing programs, and the Tutor programming language, created in 1967 by a zoology graduate student named Paul Tensart. Tutor made courseware development way more productive overnight, and the language caught on like fire. It would be the language of PLATO from 1967 onwards. One of Tutor's fundamental innovations was answer judging, which I'm sure you'll hear more about tomorrow in the panels. In late 1966, the PLATO project had outgrown CSL, pretty much taken over the building and became its own organization, the Computer-Based Education Research Laboratory, or CERL for short, reporting directly to Daniel Alpert. Tomorrow morning, the first session is on the culture of innovation, both at Searle and at Control Data, where you'll have an opportunity to hear firsthand the kind of environment that enabled all of this to come about. The National Science Foundation poured millions into the next generation of the system, Plato 4, in 1972. It had new terminals costing around $5,000 each, with built-in touchscreens, plasma display panels with 512 by 512 very friendly orange pixels, a built-in color microfiche projector inside with mirrors, a support for interactive audio and other peripheral devices like the Gooch synthetic woodwind, one of the first computer-controlled synthesizers pre-MIDI, built at Searle by the music group and who did seminal work with music on Plato. The sheer scale of Plato 4 was starting to get very interesting. 1,000 terminals, many thousands of students in everything from kindergarten to college. A growing developer community hungry for features and exchanging know-how. And as we'll learn tonight and tomorrow, all the factors were in place for the first real online community to be born. And nobody expected it. It wasn't what NSF paid for, but there it was, as if overnight. The open, enthusiastic culture of Searle became a mecca for all kinds of people, young and old. Within a span of months in 1973 and early 74 emerged email, instant messaging, chat rooms, message boards, the world's first online newspaper, multiplayer games, and creative animations and emoticons. And here's just one tiny example of the kind of handmade animations inspired by a Star Wars movie you might find waiting in your email or in one of the public notes files on Plato. All this handmade, just moving typed characters around up and down, backwards, forwards, in the text editor, no programming at all. Try that in ASCII. Dave Woolley, who you'll hear on tomorrow's online community panel, once wrote, Plato was an accidental community which emerged spontaneously in an environment that had been created for other purposes. In 1970, few suspected that a human community could grow and thrive within the electronic circuitry of a computer. Plato demonstrated that this is not only possible, but inevitable. Dave created Plato Notes when he was 17. 15 years later, Ray Ozzie, who'd worked with Dave and others at the programming staff at Searle, would release Lotus Notes. 1973 was an incredible year in the history of social computing. So many killer apps, and Plato users in this era, I always feel, were truly the beta testers of the future, the very future that we take for granted today. And yet so few know about these things. Look up any history of the internet or history of social media, and you may not see any mention of Plato at all. So I was curious. I wondered where were today's technology luminaries? What were they doing in 1973? And a few were working already. Some were in college or in the process of dropping out. A whole bunch were in grade school or high school. Few were in diapers, including the founders of Twitter, YouTube, and Google. And a few hadn't even been born yet. The founder of Facebook would not be born for another 11 years. Control Data Corporation, which had begun its long relationship with Plato back in 1963, would enter a major contract with the University of Illinois in 1976 to license Plato and market it to the world. Bill Norris, the founder of CDC, was a huge fan of Plato and a major believer in the idea that computers could be used for social good, not just number crunching. Two other executives from CDC are here with us at the conference. Robert Price, who became CEO of CDC in the early 1980s, and Bob Morris, who oversaw the CDC division in which Plato was housed. So where is Plato today? By the early 1980s, Searle and CDC decided to pursue different directions. Bitzer's group formed a company from which sprung Novanet. Novanet is still around, profitable, has typically 10,000 or more simultaneous users on it every day. It's making a difference around the country in remedial education. CDC would eventually sell its Plato business, including the trademark. Today you can find most of CDC Plato DNA in Plato Learning. which also successfully sells computer-based education solutions to schools. Between Novanet and Plato Learning, the Plato vision is still very much alive. So a quick summary of tomorrow's agenda. Tomorrow we're going to start off with a wonderful discussion about the culture of innovation at Searle and Control Data. Among the folks on this panel is David Frankel, who started working at Searle when he was 12, 3 years after this photo was taken. Then we'll get to hear from some of the original authors of Plato courseware and find out and why they built the lessons they did, how well these lessons performed with students, and how things have gotten better in today's e-learning world. And in some cases, current practitioners have yet to reproduce the results achieved on Plato. There's a great software panel moderated by Steve Gilmore. We'll have a hardware panel and you can learn much more detail about all the amazing engineering that went into building Plato. Games. The great irony of Plato in some ways. Here was a system whose mission was to improve education. But for many a college student, nudge, nudge, wink, wink, it would cause them to flunk out due to all the all-nighters in Empire, Avatar, Airfight, and other games. You do not want to miss this panel. And online community featuring some of the very authors who built the killer apps back in 73, 74. I'm sure it's going to be a fascinating conversation. But to get things started, we're going to have a great conversation right now with John Markoff, Ray Ozzie, and Don Bitzer. Thank you so much for coming. Welcome to Plato. Enjoy the conference. Thank you.
Well, as Brian has said, we're about to go into the conversation now. And if you've ever wanted to eavesdrop on a conversation between a mentor and a mentee, both of whom went on to titanic accomplishments in computing, you're in for a treat. And the person who will lead the conversation between Ray Ozzie and Don Bitzer is John Markoff. He's a good friend and a regular participant at the museum. Many of you will know that John writes about technology from Silicon Valley for the New York Times. His coverage is one of the most closely watched barometers of what's important and new in the tech industry. He's been writing about it with authority since the 1970s and with the Times since 1988. He is, as a colleague once said, a tech writer who sells newspapers, which is a remarkable thing. He's one of the best moderators in the business. He's going to bring our panelists to the stage. Please join me in welcoming John Markoff and our panelists. Thanks.
So I am particularly eager to take part in this conversation because I grew up about a mile from here, and I was pleased that in the 1970s I found my way into the ARPANET through an unprotected, unpassword-protected tip at NASA Ames and to MIT AI. But I had heard of Plato. But Plato, for me, was the computing castle on the hill. It was mythic, and I've always been fascinated by the things I didn't know, and so I'm hoping I can learn a little bit about it. Let me first introduce my co-discussioners, and then we're going to have a short additional slideshow, which I'll drive and Don will narrate, and then we'll chat. Ray Ozzie, I think, is probably the clearest example of the impact and influence of Plato. He is now Microsoft's chief software architect, as you've heard, and he's best known for his role in developing Lotus Notes, which, of course, was inspired by Plato Notes. He grew up with the personal computer industry. He was hired at Software Arts in 1981, where he worked on VisiCalc, and then went to Lotus in 1983, where he worked a bit on Lotus 1-2-3 as well.
Symphony.
And on and on. In 1984, he founded Iris Associates, which developed Lotus Notes. Those ideas would later evolve at Groove Networks, which was purchased by Microsoft in 2005. He has a computer science degree from the University of Illinois at Urbana-Champaign. Don Bitzer is the father of the Plato system and the co-inventor of the plasma display. His early interest in electronics was sparked by an uncle, I understand, who helped him build radio sets. And he was a devotee of popular mechanics and popular science as a teenager. After studying electrical and computing engineering at the University of Illinois, he became an assistant professor at UIUC. He developed the prototype Plato system in the early 1960s and realized early on that better display technology was vitally needed. He continued to pursue the development of Plato and plasma display technology until he left the University of Illinois in '89 to become a distinguished university research professor at North Carolina State University. So we have some slides, and I think if I press the right button, maybe something will happen. Can you see the one?
Sure, I can.
Why don't you tell us what we're looking at?
Yes, I think that in order to...
Oh yeah, you can move forward. Good, good.
That's a plasma panel. That's good. I think in order to understand what was driving us to make things happen, besides the social need, I stood in line too many hours to get my code check done. Burnt too many fingers on the person putting the tape in who didn't like me after that. So I was very anxious to solve this problem not only for education, but to make sure that we all had decent access to programs, programming and testing our programs. But in order to do this, we had to have all new technology. And I hate to put it this way, but what you see there on that first picture is some of the new technology. That was a television set that we got from a repairman for $15 because the only part of it that worked was the video section. But that's all we needed for what we wanted to do. And our budget was fairly small. There were 2.5 of us building the whole project. The other thing I want you to note in the picture is that keyboard, which I think you'll see a larger picture of later. And if you look at that keyboard, you'll see what a keyboard looked like. You didn't have keyboards. They had some teletype machines, but you had to make your own keyboards, if anything. And that was a 16 keyboard, 16-button keyboard, and you'll find that we had to teach several different lessons with 16 keys.
So it was not QWERTY.
It wasn't pretty. Not only that, it was impossible to do with 16. So we fixed it so the computer would change the lighting from white, regular light, to ultraviolet. And we had painting on the keycaps, which would change what they meant based on what set you were supposed to be using.
Okay.
And then later on, I'll tell you about that little set.
We're going to the next slide.
There's a larger version, larger picture of the keyboard. You can see what the keyboards were. There's some interesting keys on there which we can talk about later. One of them is the next button, which means you went on to the next place, next piece of information. If you got in trouble, you could push the help button. And the help button would then take you to a sequence that would help you solve the problem you were on. And then there was this button called, the famous button called AHA, which meant if you were getting help and you no longer needed it, you didn't have to wait around going through all the extra. You push the AHA button. Then there's erase, and there's something called a replot on there, which was caused only because of the technology we had, which would build up iron spots in the middle.
Was this talking to the iliac 1?
This was talking to iliac 1 through a set of inputs which we had on our floor, because other things we were doing in the lab at the time was we did aircraft control. We did it, first of all, to defend the fleet, the NTDS system. How do you take in all the radar images and key in results and defend fleet? And then we turned it around to how do you land the aircraft, trying to bring all the information in together. And they learned a lot about things like that. So we already had a connection that we could connect to and get to the iliac 1, and that helped a great deal.
Okay. Next slide.
Well, you can see that that type of terminal that took a whole video channel per student wasn't going to go very far in either distance or numbers, because the TV set required a video channel. And if you had 100 terminals, you're going to have 100 video channels just to support the 100 terminals. And price for running cable was even worse than the price for memory. So, but you couldn't do it without something like that at the time, because memory was too expensive and there was no memory for you to remember what was written by the computer. So we decided that in order to solve that problem, and I'll tell you more about what we did before then later, but in order to solve that problem, we were going to have to invent something new. What you're looking at is the artist's conception of what we decided we were going to have to do to solve the problem. And if you look at a terminal, you'll find out it looks very much like the artist's conception. We had to have this thing we called plasma panel, which didn't exist. We needed to design better keyboards. We needed to have a projector for color images, a microfiche projector, which we had to select images within a tenth of a second. And we eventually had to add audio and other things to it. But it just didn't exist, and so that was our goal. We had a mission. The mission was to be able to do something like this remotely over phone lines and not have to use expensive equipment.
And this was sometime during 1960 that this was drawn?
This was drawn in about 1963.
Early on.
Final image here is we decided to go to work and make one. This, you notice, is in orange, and it's a 16 by 16 plasma display. And it's, if I showed you the one before this, but I was going to wait till later, tomorrow, you would find it was all blue. And there's a story as to why the first one was blue, and this one had to be orange, and the luck of invention that goes with it. And it's a whole separate story. But this was our first really operating display. We won an award with this one for the IR 100 when we were able to take this in a small container with us and show people how it worked. You played the keyboard like a musical instrument to write in on it because you didn't have positions. You just had to put them in binary very fast.
Do you remember how quickly you could refresh the pixels?
Oh, that's a whole different story. the pixels are actually refreshing approximately 100,000 times a second. Okay? And again, that allowed us to do all kinds of things. You could erase a dot, you could write a dot, you could refresh the whole thing or any cross-section within that period of time. That was the cycle time on it, which allows us to use it now for television, which is another problem. We did this to improve education. We made this terminal. I insisted on it being one that we were concentrated on solving the educational problem. But you now notice how it's turned out. It's now the colored plasma TV. And instead of students rushing in to see their terminals and learn, they're all rushing home to turn on their plasma TVs. And maybe we made a big mistake.
Oh, that's the bigger question that we'll get to. So those are our slides. Oops, no, they're not.
Okay, well, this is the last one. And what you want to see here is how a newspaper reporter responds to these events. I thought I would throw that in.
Blame the messenger.
Yes. It turns out that Control Data Corporation was starting to dive in and help us with the displays at the same time. Now, this is when we had that, one I haven't shown you yet, the 4-inch by 4-inch, in 1966, and the science reporter from the Chicago Tribune came by. And he said to me, we hear you got something new here, can you show it to us? And we did. It was this rather small image. You had to look very carefully or you wouldn't even see it. But he looked at it, and his first reaction was, this is a vision plate, wired brain, it's going to be a television set. I said, it's not going to be a television set, get out of your head. First of all, television is multicolored. This is orange, you got to like orange a lot. Secondly, it's one shade of gray. Television's many shades of gray. Now, we knew how to solve some of those problems, but that was not our mission. We wanted to stick to our mission of solving this problem. And he kept telling me things. And then he said, well, it's this and it's that. And I said, please, just listen to me. This is for the terminal. Well, he didn't pay any attention. He went out and he wrote his article as if I told him that it was a television set. It was 30 times brighter than normal sets. What really was a duty cycle was 1/30th. And this got put into the Minneapolis paper where CDC was working. And this is a letter, probably from someone already in the audience yet here from CDC, who wrote me back and said, isn't this a bit of an exaggeration in black and white or full color? Yes. And then it got down where it was worse, 30 times brighter than TV. And then he asked me if I would introduce him to our press agent. They could use him at the CDC. That's every fear. Now, I have to tell you, he was right. He had a wider vision of what was going to happen than my focus vision. And so now I disclaim this. I say, yes, that's what I told him. And there it is. Oh, I don't know how this got in there. But,
another application.
Yeah, but these are different applications, but we need to focus on these in this talk.
Okay, we'll come back to that. So we're going to dive in, but before we do, I want you to all know that there are some cards and you can write questions and they'll come up to me. And so if we miss things or you have things that you want answered, please feel free, and I'll go through some at the end of our... And then the other thing I want to say is I have some questions for Ray, but I want to deputize him as co-moderator because he has long experience here. But what I want to do is I want to start at the beginning, because there's a lot has been written that I've read recently about those first discussions about an automated teaching system in 1960. And I wanted to ask, were you part of those discussions?
The original ones?
The original ones that...
No, I was in the laboratory. I was working on another project, but I saw them. They were across the hallway from where I was working, and I didn't hear the fighting. The doors were shut. But it was clear from watching what was going on that that wasn't going to go anywhere.
And had you been thinking about teaching machines before that?
Well, I thought about teaching and the possibilities of using the computer for teaching, but I hadn't sat down with any mission of getting something done until I read the letter from Dan Elder.
So they came to you out of the blue, basically, saying, we haven't figured this out. Will you help us figure this out?
Well, he threatened to send the letter to the dean. And when he said that, he said, do you agree? He wanted me to agree with him to get him off the hook in case they were wrong. And I said, no, I don't agree. Give me a week, and I'll tell you how we're going to solve it. And he was a friend, and he said, you got it. A week and 1.5 people with you. So we went to work.
And so I know what Plato stands for, but did you start with Plato, or did you start with the other side of the acronym, or did you think about Aristotle at all?
We started with Plato, and that took the first week of research. We had a meeting the first week, and Peter Braunfeld and Shal Sherwin and I met, and we would talk about, we each came in with names. And I came in with the name Plato, and I said program logic for automated teaching operations. And Braunfeld, who was a language expert, turned to me and says, no, we can't say that. Automated means self-mated, and we don't want to give that image. We'll call it automatic. And so we made that change, and that was it. Then we got down to work.
And was there something about Plato's philosophy that you were thinking about at the time, or was there an educational component to it?
Well, yes, we knew, we of course knew about Plato. We would like to have some acronym which would carry the message with it. We had years of experience in military projects, so we had a good handle on how to generate all kinds of acronyms that might get money. And we thought it was an attractive name. It didn't seem to alienate anybody, and sent the message. And we stuck with it and never changed after that.
Okay. So before we go on with Plato, I wanted to step backwards while we still got a chance, and I want to ask about your first contact with computing. How did you come to computers, and did you have wide experience with computers before Plato?
There weren't any, really, computers. The first computer at Illinois was the ILLIAC 1. They also built 2 others. They called the ARDVAC 1 that they sent to Ordnance Proving Ground, and another one they sent to, it's called the CILLIAC. It went to Sydney, Australia. And when they built those 3 and shipped them, they said that takes care of computing now for the next 10 years. They didn't understand that computer users and programmers, as Ozzy will tell you, are like ideal gases. They'll fill any container and put them in.
That is for sure.
It wasn't long before they were proven wrong. And all that. But that's essentially where we started. And I was an undergraduate. No, I wasn't. I was a graduate student at the time. And I got interested in using the computer. I helped them through some of the finishing touches and programming all for the ILLIAC 1. But generally speaking, I used it for all my courseware, which gave me a great advantage over most of the students who didn't know how to use the computer.
And at that point, you accessed the machines with panels, toggle switches, or with card readers, or what was
Paper tape.
Paper tape.
Out of a teletype machine. And the hexadecimal system, which everybody used then and uses today, is called, it's now called 0 through 9 ABCD. In those days, it was called 0 through 9, the letters, KSNJFL. And the way you remembered that was kind souls never joust fat ladies. And the reason for that, I have those symbols, is that we had a teletype machine for input, 5-hole teletype. The 5th hole was a carriage return, and if you typed 0, 1 through up there, that's how many holes it punched in the first 4. When you got to 10, you hit a K, and it punched the right holes for binary and 10 at KSNJFL. So that's how it got the name, and they changed it later.
And was I right? Did your interest in technology start with radio sets? Is that a true story?
That is a true story.
Were these crystal sets or more? What generation?
No, I remember this. This was just after World War II. Well, during World War II, even when we built some of these. And so I built. I was interested in super regenerative sets where I could get London and so forth, and the techniques of the problems that went with that kind of building. And I had an uncle who was very good at all that. It was his hobby, and so we built them, and I would burn them up.
And you entered school as an electrical engineer? Is that what you studied first? Or was it?
I entered school as an electrical engineer, and in fact, I decided probably when I was about 5 years old, that's what I wanted to be. And it never changed my mind.
So I wanted to ask about sort of, everybody mentions Sputnik as a driving force. You know, it clearly led to a lot of money flowing into the system, but I wanted to ask about the mindset that you had in the laboratory. And was Sputnik, you know, were you designing in the shadow of Sputnik? Did it feel like there was a competition? Did you feel like you were in a Cold War? What did it feel like?
Well, in some sense, it was embarrassing. We had, when Sputnik went up, I rushed into the CSL laboratory and grabbed all of the radio receiving equipment and checked it out partially. We ran out to the airport, set up antennas, and measured what was going on, the period and all. And from that, I mean, we did a fine, nice job of tracking Sputnik. But what was embarrassing about it wasn't so much that the Russians were able to put up Sputnik. What was embarrassing was that we had been trying to put a rocket up for a long time. It was they used to call it they called it civil service as a nickname, and that was because it wouldn't work and they couldn't fire it. You read about these things. So finally, they turned it over to the military, and we made a lot of progress.
When you sat down to answer the question that was posed by Alpert, was there an overarching educational vision that you had? I mean, what were you trying to accomplish when you put together the first idea behind Plato?
I was looking at the overall educational side of things, not any particular courseware. I was interested in knowing what are the components that you need, and that's what led to having the best display you can get. Because if you want to be flexible, you really need all the components of a very flexible display with graphics and pictures and sound and everything that you can work together as a team. Because it's hard enough to teach without being handicapped by restrictions on the medium that you have to use.
And what about educational philosophy? I mean, was your original vision broader than drill and practice right from the start?
The original vision had no drill and practice in it. That came later. When we got to the drill and practice for kids, we souped it up a little. We used to have a little M&M dispenser at each. And when they got the problem right, it would kick out an M&M for them. If it rolled on the floor, they didn't go on until they got their M&M and put it back in. So we were not above any kind of bribery to get students to study. So the drill and practice, even there, was quite unusual. And the way one would decide what problem to give next was also well thought out. So drill and practice was not the main component. The first thing we did was something to do with geometry. Then we did French next, which was a language. We were interested in testing the limits of what we had done and what we needed next to complete the mission.
Yeah, right.
One of the things that always fascinated me, I'm not sure how many of you worked at Searle in that era. Are there a lot of you out here? Yeah. Something I know that every one of them would echo is the fact that the environment within which this was created was just an incredibly unique environment. And the way that I've approached building teams, building projects over the course of my career was I can go back to the experiences that I had at Searle, good, bad, and ugly. And it always made me wonder what were the things that were what were the root causes for some of the ways that you organized or didn't organize. What were the early projects that you were exposed to, in your formative years that gave you your attitude? Because clearly, so much of what Plato was because you just set a path, or whoever worked for you set a path and just felt, no, we can accomplish it with whatever constraints we have. We can solve that problem. There was just never any doubt that you could find some clever way of doing it, and that requires a certain process. It requires a certain type of people that you gathered around you.
Well, first of all, they were all very bright, and particularly in their own way. They were young, which helped. They weren't biased. They really thought you could do things, and they believed it. They didn't have to listen much because I didn't really have to tell them much of anything. They were anxious to get to work and get their job as they saw it done. I felt that my position was making sure that we stayed on target for reaching our goals, but to make sure that I didn't get in their way and that they didn't get diverted by having to go get funds or work on this. My job was to solve all their problems so they could concentrate on doing the things that they wanted. And even 10-year-olds appreciate that, and so did the other high school students and the college students, but almost everybody was very young. And that was really very nice because they were receptive to ideas. They didn't believe in defeat. In fact, we didn't know what defeat was. I can't picture any case where we really felt defeated and quit on anything over the years.
On the East Coast and the West Coast, there were these laboratories that spawned what was called hacker culture. In the white hat hacker sense of the word in the 1960s, as described by Stephen Levy. Where would you frame your laboratory in that context, if you're familiar with the, SAIL and MIT AI and Doug Engelbart's Augment Lab? Right. Were you of a similar cultural?
We were slightly different from that. First of all, our mission was broader. It wasn't just an object or a product. We had a very broad mission, and I was really serious about that mission because at that time, over 50% of our students coming out of our inner city schools were functionally illiterate. And I thought, if we don't solve that problem, we don't have to worry about any others. So we worked very hard, all of us, at trying to solve a real problem, and we concentrated on everybody moving towards that goal. And there were plenty of different directions to go to get near that end of that goal. So we were different that way. And I don't think I would view the people that work for me as hackers. They did magnificent jobs, well done, well thought out, concentrating on important matters that affected humans. And as long as we were heading that way, I always felt, we're going to be successful.
Did any of them get seduced by the power of the computers? Was there this sort of behavioral quirk of coming in at midnight to get access to the machine cycles?
They all did that.
Had no choice.
We had to, and so many of them were young, under 14. So we had to, the police asked us, we had a curfew. And the police asked us to get them out of there somehow because they didn't want to stay all night. And what we had to do was we had the system automatically know the ages of all the people who had sign-ons. And if they were underage, it would kick them off. Every minute they sign on and kick them off after 10 o'clock until they got disgusted when they go home. And that satisfied the police trying to get them back home. But we had all kinds. There are people here who can tell you they crawled in through the windows when they were age 10.
And these were teenagers, perhaps even in junior high school, who were doing productive work for you.
Oh, yes. That's the other amazing thing, is that young people who are bright and very creative are not limited by the fact they don't have a PhD when it comes to many areas. They can do many of the things. There's some things they can't do because they haven't been trained yet in that area, but they're very good at creative projects, and they don't say no. They haven't gone out and read all the journal articles that say you can't do it. They read those afterwards. They say, I wasn't supposed to be able to do this, but here it is.
And the sort of decision to let the kids in, if you will, was that yours? Was that sort of just a
That was mainly my decision, with the support of Dan Albert, the director. He believed in that. Now, he had an interest in that too because his daughter was one of them that we used to get in. But she was very bright too. But I always I always supported the young people, and I still do today. Some of my finest people working in genetics were students, high school students. When they were juniors and seniors in high school, they already finished differential equations, were working on quantum computing at the university, and were bright and creative, and they won the Siemens Prize a couple 2 years ago.
And I can tell you the feel of the environment was just such one of meritocracy. I mean, if you could do something, if you had a passion about what you were doing, you could find a way in. You could find some way to get your author records and start building something. Somebody would share a password so you could see how a lesson was built, and people would stand on the shoulders of each other's work.
Ray, how did you find your way to Plato?
In short, I had started programming in high school in '68. GE 400, time-sharing system, teletype again. When I got to University of Illinois, we were using a 36075 with key punches, entering programs, submitting them in batch. And as I would walk back to the dorms, I had to keep passing this building. And depending on how late at night it was, you'd see this friendly orange glow, out of the windows. And I had never used a graphics terminal. I mean, I had used teletypes and things of that nature. And I walked in, and you could see these people, and eventually I found out that you had to be a student in a course. So I wangled my way into CS 109, which happened to be a computer science course that George Friedman was leading this course, and he got me some author records, and I programmed a logo interpreter. And eventually I learned about the ranks, about the hierarchy, about the fact that there are users, then there are authors, or instructors, then there are authors, and there are batch, then there's operators, and then there's student systems programmers, then the real systems programmers. And, I just wanted to get in. And so you do what you do. You just start begging. You could try to steal somebody else's author records or whatever. But everyone had their own technique, but you had to find a sponsor. You had to find someone who had disk space, had some blocks and had the ability, had a group that they could provision you with records. Ultimately, I wanted to become a systems programmer, so I got to know Paul Tenzar, and he placed a bet on me, gave me, put me in this group Batch, which had special privileges, and we had to, as systems programmers, we could only really use the system or run test code from 10 p.m. till 6 a.m. And this was called non-prime time, when the students were more or less using it at their own risk. And it was only 1 hour into having my batch records that I wrote a lesson and tried this new read ECS command and crashed the system. And I went upstairs, and Rick Blamy gave me this incredible stare down, and it was a while before I did that again.
So no memory protection.
No,
really.
no. Well, the system was protecting itself against clowns.
And how did you meet Don? At what point in your...
Don was a mythical figure. In essence, what Don was trying to do, what the project was trying to do was carried, it flowed through many, many, many people, and there was a mythology. We were talking earlier about the fact that you were on the Phil Donahue show, which was a big talk show at the time in Chicago.
What were you on for?
Well, they needed someone besides a deviant for the program, and they decided that this might be a topic which would settle all the letters they were getting on the program.
But as anybody who's run a project or gotten financing knows, you have to inspire the people around you, and you have to sell. You have to always be selling for that funding. And Don was on the road a lot. I know that You had gone to, in that time frame, 74, 75, you were going to Moscow, you were going here and there, demonstrating it, maybe putting pockets of terminals here and there. But, the culture, if I could, for those who lived in it, it left an indelible impression. You had hardware people, you had software people. We were building prototypes of new kinds of terminals. When the mainframe, ran out of memory, we built this thing, or the group built this thing, AMS, that just expanded the memory of the mainframe. There was nothing that couldn't be done, and that was the spirit.
Wondering about a parallel. It may or may not work, but I wanted to ask you about it. I think ILLIAC 1 preceded even the concept of supercomputing, as I understand it, although ILLIAC 4 maybe was considered kind of an exotic supercomputer, perhaps. But, later in Champaign-Urbana, the first browser came out of a supercomputer center, and I was just wondering if there was any kind of parallel that's interesting, that Plato grew out of ILLIAC, but not in the same way, perhaps. Is there a connection that's worth?
The biggest connection is many of the people, or some maybe I should say, not most, that worked at the supercomputer center had worked with me first, and they went over there and remained friends. And I think that the story of how the browsers got promoted and finally pushed out into commercial use is a story all in itself, of which I think that there was at least a section in the supercomputer place for a while which promoted this kind of activity, because I don't think they were probably checked on either for what they were doing for a while, and they were able to get things set up before they got shut down and these various effects. But I think that's the big secret, is to keep people working without being bothered and shut down because they got some idea that you may not agree with. And that worked out, in our case, most of the time. We once represented, I think, 90% of the royalties at the University of Illinois. And so the management school, College of Commerce, decided to send over some of their students, graduate students, to study our management style so they could talk about how to create these kind of places. And after about a month and a half or 2 months, they went back and they reported that there was nothing to report, that there was no management. And I think that it wasn't quite that bad. I did have organizational structure underneath, but no one was beaten up for trying something new, and they were given time to try it. And no one felt like they were going to be kicked out because they didn't meet some particular deadline.
And each person who was exposed to something on that system, it more or less left an impression, and you would build on those ideas. In no matter what project you went into. Those of us who were on the system in that era got a little bit of a sneak peek at what all of us experience on a day-to-day basis on the internet, the notion of online community, the notion of computer-supported cooperative work, the good, the bad, and the ugly of what happens in online settings, interactive gaming. It's funny. So many different things have come to pass that have some chain that you can follow through, that is rooted in the experiences.
One that I think is not so well known. Maybe you know this story well, but I think Alan Kay credits seeing your plasma display as a big part of his inspiration for the Dynabook. I mean, he understood that it was possible when he saw the plasma. I think maybe David Liddell was a graduate student working on some aspect of plasma displays, and what are sort of, that's a sort of indirect spin-off, but it's one that sort of had a huge impact on the world. I guess the Xerox PARC people actually came and visited you during the early 1970s?
They did. They were our friends. Kay was glad to have him come. We did talk about things, and he knew where we were heading. But one never knows what was transmitted, that transpired, that inspired him. I never know what's in a person's mind or what put it there. But we sure tried to expose people to everything that we could because we wanted all the help we could get.
Well, let me ask Ray what the path was from Plato Notes to Lotus Notes. How direct was it?
Oh, it's very direct, very direct. No, I mean, look, we lived within this environment. So many people flunked out of school because of passion about what we were doing. People would work all night long. You don't have much energy left to do other things during the day. You party with your friends. You spend all summer there. You become part of the environment. The environment becomes part of you. When many of us left, we tried to recreate many of those things that we loved that we really hadn't experienced computers without those things. I mean, remember, this was the first, at least for me, this was the first system with a terminal, let alone interactive and so on. And so when I left University of Illinois and I went to Data General, most of my friends, some out here, went to DEC. We went into environments that were developing commercial computing. And yes, we'd advanced to better terminals, at that point in time, but it was boring. I mean, it was just boring computing. Whereas on Plato, we had all this, it was life. There were people behind the screen. And so many of us just set out to recreate, whether it's a tool here or a tool there or something much larger, to recreate some of that excitement that was on there. I know, and Notes was something that many people tried to recreate. I think Rob Kolstad did it on Unix. Len Kaywell did Knotes on the VAX. And then Tim Halverson, who was a systems programmer, Len, who was also a systems programmer on Plato, and I were co-founders who did what ultimately became Lotus Notes. It was codenamed Notes. We believed in a decentralized architecture that was more modeled at the time against Usenet, UCP, more or less replication protocols. But the goal was to recreate an online community within an environment, a commercial environment, where we could make money selling that kind of a system. My view, and I think a number of people's view, was more or less a more static system that recreated many of Plato's features. Len Kaywell, who I think is here, argued for more of a self-programmable environment, which was really what made Plato so successful, because you get so many unintended consequences. And the rest is kind of history. But one of the things that I think many of us learned on Plato and then subsequently in these things is if you pick the DNA elements the right way, you can create some just amazing things on top of it.
In terms of the diffusion of ideas, I mean, you took the ideas out, but I've wondered, it felt like in the 1960s and 1970s, the computer laboratories were relatively isolated from each other, but some of the things you told me before we started suggested you actually were in pretty close touch with a lot of people who were doing parallel research. You would meet with Doug Engelbart, for example. Did you know about the mouse? Did you think about I want to ask about user interface, and this is a way in. Was the mouse on your radar? And
The first time we demonstrated a small plasma panel, which was a conference out in California, Doug Engelbart demonstrated the mouse in a program. And we looked at that, and the problem we viewed from the educational standpoint was that we had a lot of students who may be handicapped and or small children who might not have the motor skills. And we want them just to be able to touch what they wanted and know when they touched it. And so we decided to proceed with the standard terminal being one of touch. You could add anything else you wanted, but that was always on there.
Speaking about touch, what did you think when you saw the iPhone?
Oh, that's amazing. And I tell you, I have probably as much appreciation for that as anybody, knowing what's involved in sensing the touch, making things move, the programming that's going on. That's amazing stuff. Even I didn't think of that. Of course, there's a lot of things that I wouldn't think of that they could do, but they've done it. And makes Dick Tracy look pretty obsolete, doesn't it?
in exploring, when you developed your touch interface, did you explore some of the things besides a single finger pointing? Did you use multi-touch or zooming or any of those ideas? Did you explore any of those ideas early on?
The only touch that we used to any extent was the one that would sense where your finger was. Now, the software that you put with that, to make it expand or move it or whatever you want to do, that's software. And so we would separate the hardware that would give us the signals from the software, which would give us the output. And so we try to departmentalize the various areas. We used to say that the software people used to say we have to stay up all night to get the software working because the people in the hardware aren't doing their job. Everybody blamed everybody else if things didn't go smoothly. And then we have covenants, and if whoever broke the covenant had to pay. They had to buy Cokes for everybody else in the other group for a week. And that was enough to drive them to try to make it right.
So, writ large, in sort of the arc of Plato, what do you feel succeeded most, and where were your disappointments in terms of sort of the technology that Plato brought to the world?
Well, I think it's easy to say where we succeeded the most. We succeeded the most with people. Two kinds of people. One is we succeeded with the students. Even today, there are at least 100,000 students who are in school, still staying in school because they get access to these lessons. We succeeded with people who learned how to do new things and be fearless about it, take chances, be entrepreneurs, take on new ideas. Those people are out there today. Ray Ozzy's one, but there are dozens sitting out here who tell you the same story, and that to me was a major success, because when you have hundreds of people out there who had this experience and know how to proceed, they'll eventually work their way into places and come up with new ideas and new things, and that's what makes it a better world.
I wanted to ask you about meeting William Norris and what the cart and the horse aspect of his interest in Plato and his passion for sort of some of the social issues that he wanted to use Plato to address.
Well, first of all, I like to give a lot of respect to Bill Norris. Bill Norris was a very good person. He put his money where his mouth was all the time, and he was very socially minded. And the reason for him being that way was he was born on a farm, and the only thing one year that they had were these balls of hay rolling through the fields. And the family was about to go under, and he figured out how to take those and treat them so they could feed the cattle and save the farm. And he's never forgotten that. So during his whole career as head of Control Data Corporation, he was always interested in helping people solve these kind of problems. And he got involved. He said, we're going to build computers, but we're going to build computers with people in areas that need help, areas that are poor, areas that you may not think you can find the workers. Of course, he said, now we have to educate them, and we're going to have them make the most important component to let the world know that we're serious about this problem. And so he would then set up a Plato system for teaching the new people how to put the system together, how to manufacture and all, so that they would, in fact, be able to do these important problems, solve these problems for control data. So Bill was a visionary. That's a tough job, because now besides having to start up a new division of a company, put in new products, you have to worry about cost of education, putting in a whole new system of education for teaching these people. But he was a visionary, and he worked very hard at it, and for the most part, he was successful in that way.
I wondered about sort of the limitations that cost presented you with. Computing was very expensive. Educational systems, as a rule, didn't have a lot of money. And in the 1970s and 1980s, when personal computing came along, what was your attitude about the personal computer? I know there was this thing at one point called MicroPlato or something like that, but were you guys quick, slow to take advantage of personal computing? Was it an opportunity?
We had three different approaches. One was the microcomputer. The other was a mid-size, classroom size, which is now known as Plato. And then we moved on to we had a central system, which eventually became known as NovaNet now. So we did all three of them because you never know how the world's going to change. But I can remember the CDC telling everybody once when they said, telephone lines are so expensive, we're going to have to solve all these problems with standalone micros. I remember telling them that I wouldn't worry too much about that in the long run, maybe in the short run, because eventually everybody's going to want to be connected together. And you're not going to do that with micros alone, but they make excellent terminals later on.
Did you ever resist gaming as part of the Plato culture?
Depends what type of game. I liked more of the interactive sports games we had, where football teams could play each other.
So you were a gamer yourself?
Oh yes, but the games were much better than they've given them credit for. They'll tell you that at the game session, but there were games that taught students to do things that they would have never done otherwise. For example, you may have students who were not very good at school, but you wanted to teach them how to use a protractor. And so what we would do is we would give them this game called Moon War, where you shot things off the edge and side and they come back and try to hit the other person from behind the rock. Well, it turns out that to do that right, you have to know what angles to shoot. And we would say nothing to them, but before you knew it, they had developed this piece of cardboard, which you could call a protractor, for calculating all these angles to go with it. And there were a number of games like that that I thought were very educational and carried the message that would have been hard to carry otherwise.
To what extent did the gaming drive the Plato online community, and to what extent did the online community feed back into gaming? Were those two things separate, or did they really sort of emerge together?
I'd have to say yes to that for both. Sometimes there was gaming going on, particularly on weekends, around the country. And we didn't mind it too much on weekends because we weren't delivering, it wasn't interfering in the delivery of education. But sometimes they didn't know when to stop or start up at night. And frequently we had to block the games in certain areas in certain classrooms because there was such a desire to play these games. These games lasted 12, 14, 16 hours, sometimes on the weekend, with all these people playing. Now, I think these games served a purpose. I think the people learned something from it. Now, they might have learned a lot more if they'd been in the classroom, but it wasn't completely a waste of their time. And besides that, there was no way of stopping them. I mean, people do what they want. We had... Well, I think, wasn't one of the Netscape people, I don't think he got his degree either. I think he didn't graduate, but he did all right.
There were a lot of great developers who developed their skills from very clever techniques that you had to use. You had a certain amount of shared memory, common variables, a certain amount of other, you had certain restrictions. If you had to do things in a calc command that if you want them uninterruptible, there were a lot of things that the constraints forced creativity in development, and that really helped a lot. And the other thing I want to say is the gaming and the communication tools, whether it was TermTalk, Talkomatic, notes, personal notes, group notes, they fed off each other. They were both. They both reinforced the community. Not everyone was a gamer. Not everyone spent as much time in all the different notes files, that were out there. But together, it really drove a very, very healthy and diverse culture.
Were there any rules? I mean, what were the limits on somebody developing a game and deploying it? Was there anything like an app store?
If you have a sponsor, someone who has some extra disk space, some blocks of disk space, and they're willing to kind of go to bat for you when someone else complains about you. And it is important, that it really
and
is.
Who had access to disk space? Who was allocated disk space?
Ultimately, I had a person in charge of that, and they were more strict than I would have been. But they weren't that strict. We used to, really the secret was to get a sign-on. If you got a sign-on, you could always find space. Somebody would always give you space. And you got to know everybody this way. So
You offer to write a lesson for someone,
Sure.
and then you steal a little bit here. And a lot of games had funny names, funny lesson names.
remember, these were very creative people. And they figured
Part of the culture.
part of the culture, and I never got in the way. I would get a lot of reports. You know, we ought to do something about this. We ought to do something about that. But I didn't. If they weren't doing any damage, I didn't see any reason to stop creative people from expressing their creativity.
Subversive innovation.
What about internationalizing Plato? Was that CDC or was that you? What caused Plato to go overseas?
We did only a little of it. We took a few terminals and put them in Europe, but Control Data did most of the overseas distribution and talks. We would go help sell it. We would go give talks, but they would put it in South Africa. They would put it in the Soviet Union. They'd put it in Europe, in Brussels, and in England, and lots of places. Now we would go as far as Canada, from our. But we stayed pretty far away from the overseas because you had to have centers. You didn't want to be transmitting all this stuff in those days across the ocean, so they'd build a center, Control Data. And then from that center, they would set up the various schools.
Was there ever any thought given to sort of making Plato more widely available by putting it onto other platforms? I'm thinking VAX particularly, when DEC really got rolling. Was that not in the cards because of the CDC-VAX proprietary relationship?
It probably wasn't in the cards for CDC to do, but we were not bound by that. We actually changed. We built a computer. Finally, when the CDC machine was we were too large, we built our own computer. And then eventually those were converted over to commercial computers that could take their place. But you understand that everything had to be upward compatible from day one. And that meant that when you did hash coding on a 60-bit funny round-off machine, whatever machine you took on, you had to fix it up so it did the same thing exactly.
It's hard for people to remember this these days, but these are 60-bit words, 6 bits per character. One's complement, meaning there's a -0 representation. It was not a machine, and it was just a lot of assembly language, just a lot of assembler. And that's why the one that's operating out here is operating on an emulator.
We just have a couple of minutes left, but I want to go through some of these questions the audience has asked, and so I'm going to work through them. Why has Plato, something so advanced that it presaged most of what we all use every day, been so unrecognized by even industry participants? Any reason why?
Well, I can give you one reason. First of all, we did no advertising ourselves. Now, Control Data had its own problems around this time, so that hurt their commercial version. But we had Plato still running today in the form of Novanet, and also the Plato classroom stuff, from the Plato systems. But we had built systems that are still in use today, have as many as 10,000 users at one time on them. And the only advertisement really is mouth to mouth from the schools. And they seem to like to keep it that way. We build it to be expandable, but it only, somebody has to pay for it.
I'll also say that I think it was not as well connected into the research community as many other systems and efforts. It was focused on doing as opposed to publishing about the things that were being developed.
That's right.
This one's slightly different. Do you feel that looking back, Plato might have been significantly more popular had it been marketed as a gaming system instead of as an education system? If not, why not? If so, how might that have changed the history of computing?
It probably was. marketed as a gaming system. I mean, the biggest royalties were not for courseware; they were for the games that went out there, and so it's not clear what games were used for marketing when they did marketing. It was.
What are the characteristics of a subject that make it a good candidate for automated teaching?
The answer to that is it's a good teacher. A good teacher, whether they're teaching Latin or chemistry or some drill and practice, if they're really good at teaching and know how to present the material, they'll do a good job. And that happened. One of the finest teachers was the Latin teacher who taught Latin. And it was great for him because he can now handle 3 times as many students as he could before in a lot less time, so he had more time for himself. So there's always some motivation. There has to be some payoff in the long run for the individual. But you get people who really know how to teach and are enthusiastic about it, they can do a very nice job. You'll hear more of that from the courseware people tomorrow.
Here's another game question. In 1960, graduate students at MIT developed the, quote, first, unquote, video game, Space War, on a PDP-1 computer during the midnight hours. Were you aware of this at the time, or is this one of those independent developments that kept secret?
I was not aware of it at the time. And and I gave talks at MIT, and they didn't make me aware of it, so I'm not really sure. Sometimes you're never really sure what's there and is not there at these places unless you really pin them down.
Was there ever a direct port of Space War to Plato? Or
We had games like that.
like it, but it was not pure Space War. You had variants.
They might have actually been called Space War, some of them. I think if we signed on, we'd probably find it sitting there.
Played it on the console.
Yes. Oh, yes.
Here's a technical question. What was the communication speed and technology for Plato terminals circa 1975?
1,200 bits per second, right?
Communication channel was, 1,200 bits per second. And we were able to run 8 or 9 terminals off a phone line because we were able to make the communication channel about 9,600 bits per second. And then we had another communication device that would support 32 terminals off of a site controller, and you could run 32 site controllers off of one cable channel. So we had 1,024 of them, and we would broadcast that signal. So you could pick it up with the site controllers. We had ways of distributing the signal in a fairly inexpensive way as we moved along.
And for those of you who haven't seen it, I really do encourage you to go over and take a look at it and try to put yourself back into that time a little bit, because the feel was just it was just interactive. It just felt fast. It felt responsive. If you didn't get enough compute, there were tricks. You could whack on the stop key and get a little bit more computation, a little bit more of a time slice. Some people know why. But it was just a fascinating, it just felt really, really different than anything we'd ever encountered. And it's a real tribute to the engineering of, the end-to-end engineering from what happened to, to fan out to that many terminals, to the communication channel, to the design of what was being transmitted and the shared state at the terminal and at the head end of what state the terminal was in.
Here's an industrial design question. Why the wooden cases on the terminals? Why not metal?
The Plato 4s were metal, but we thought the wood looked better on the Plato 5. So the wood came after the metal. They made nice sides. It was all a matter of artistic design.
A final question. Was there a computer system called Socrates that preceded Plato?
There was one that followed it for a while in the College of Education. They called it Socrates.
And it was a teaching system?
Yeah, they've tried to make it a teaching system. It didn't last too long, and the people who worked in that system joined me shortly after that. But they came along. They thought that being the College of Education, they should be in this business. And I agree, but they didn't have the expertise to do it.
I think
Well,
we're
thank
getting
you.
the hook.
We are out of time.
If I could just say one thing,
Yeah.
on behalf of everyone here who has been directly or indirectly impacted by your work or by the people who you touched, I just wanted to say thank you.
Where are the plasma pads? I would like to thank, just before you end there, Ray Ozzie for coming, our moderator, for what a nice job you did, and the museum for sponsoring us, and also a special thanks to all of you people out there who made Plato possible. You were wonderful then, and you're still wonderful today. Thank you.
Don, thank you. Could I ask you, if you could take your seats for just one second. First of all, let me just add my thanks. Ray, you said it so eloquently about Don. Don, thank you. John, thank you for being a wonderful moderator. This has been a great kickoff to this event, and hearing your stories has just been has been fantastic, and I can't wait till we get this up on YouTube in just a couple of days. If you're staying tomorrow, let me just run through quickly what the agenda is so that you'll have it in your minds. It's also in your program. Registration begins at 8 o'clock sharp. If you're registered, great. If you came just for tonight's event, but you've been interested and you want to come tomorrow, we still have places available. Just please come and register by 8 o'clock. At 8:30, the first panel is on the culture of innovation, as you heard, created at Searle by Don and his team. Then we have 5 additional panels looking at Plato, hardware, software, courseware, games, and community. We have an incredible lineup of panelists and moderators for all of that. John's coming back for one of those, and we're looking forward to welcoming you all to that. And before we go, let me just say that for each of you, we have a gift. This is a book that is published by the museum. It's called Core Memory. It's an illustrated history of computing, a short history of computing with some photographs of the very best items from our collection. We'd like for you to take that with our appreciation and thanks. Thank you very much. Please thank them once again, and we'll see you tomorrow.